All right. So dot product, like I said, is one way to multiply vectors. There are a lot of possible ways that we could multiply vectors, but only a couple of them give us useful information. The dot product gives us lots of useful information. So a vector u in component form is u1, u2, and vector v in component form is v1, v2. The dot product, u dot v, we call it the dot product because we show the multiplication with a dot, equals u1, v1 plus u2, v2. Multiply the x components, multiply the y components, add them together. Our dot product gives us a scalar. Not a vector. We just get a number. Very simple operation to do. Multiply the x components, multiply the y components, add them together. Yes?
What again is a scalar?
Scalar is just a number, a real number. And in fact, another name for the dot product is the scalar product. And you can also, vectors can be represented as matrices, and in that situation, it's called, you'll hear it called sometimes the inner product. But the scalar product reminds us that it's a scalar. So let's look at a quick example of a calculation. Dot product is nice because it's very easy to calculate. So if u is 2, 6, and v is negative 1, 5. U dot v is 2 times negative 1 plus 6 times 5, which is 28. So easy number to calculate. There's not much to do to calculate it. Well, what we're interested in is, what does a dot product tell us? The dot product, that simple operation, contains lots of information. So let's look at what one of those pieces of information is. Any questions on the process of finding a dot product? Yes?
So dot product is just multiplication.
Multiplication and addition. All right. One thing that the dot product tells us is information about, yes?
So for the dot product, when we get it to 28, what does that mean in terms of the vector?
That's what we're going to talk about next.
Okay.
One piece of information the dot product gives us is information about the angle between vectors. So let's say that we have two vectors, u and v. And we have some angle between them. So 0 less than or equal to theta, less than or equal to 180 degrees. So the angle between these vectors is somewhere between 0 and 180 degrees. The cosine of the angle between them is u dot v over the magnitude of u times the magnitude of v. So the dot product gives us a piece of information about the angle between those two vectors. This comes from law of cosines. What we would do here is connect these two with our vector u minus v, and then use law of cosines on that triangle that we create, and we would end up with this. All right, so let's look at a quick example of this. Finding the angle between two vectors is a useful piece of information. So we want to find the angle between the vector u, which is -2, 3, and v, which equals 1, -5. I'm going to use this formula. So u dot v is easy to find. U dot v is -2 times 1 plus 3 times -5, which equals -15 minus 2, -17. We need the magnitude of u, which is the square root of -2 squared plus 3 squared, which is square root of 13. And the magnitude of v, which is the square root of 1 squared plus -5 squared, square root of 26. All of these easy things to calculate. So we're going to say that theta is the inverse cosine of -17 over square root of 13 times the square root of 26. Plug that into the calculator, just like that, and we get that that's about 131.8 degrees. So the angle between those two vectors is about 132 degrees. So if we were interested in if those vectors represented some kind of force or some kind of velocity, air velocity and wind velocity, that having the angle between them is going to be a useful piece of information. All right. Before we talk about other piece of information, I want to talk about some operations with dot products. So one piece of information the dot product gives us is information about the angle between vectors. Operations with the dot product. This is just some arithmetic rules for dot product. So u is uv and w are vectors. And c is a scalar. U dot v equals v dot u. The order that we do the dot product in doesn't matter. With the other way that we'll multiply vectors, that doesn't turn out to be the case. So this doesn't always, we don't always have commutativity. Zero vector dotted with any vector is 0. We can distribute a dot product. Just like we distribute with arithmetic with multiplication with numbers. That's going to be u dot v plus u dot w. So I can distribute that dot with the dot product. a scalar times a dot product is the scalar times either of the vectors, and we can do it with either of them. U dot C V. So we can multiply the scalar by either vector and then do the dot product, or we can do the dot product and then multiply by the scalar. And finally, this one turns out to be very important for various things that we do. A vector dotted with itself is the magnitude of the vector squared. This one turns out to be really important. And if you think about this operation, if the vector u in component form is u1, u2, then u dot u is u1 times u1 plus u2 times u2, u1 squared plus u2 squared. And to find the magnitude of u, we do the square root of u1 squared plus u2 squared. So u dot itself is its magnitude squared. This one is one that actually gets used in the law of cosines thing to find the angle between vectors. All right, we good so far? Well, let me go back here really quickly, and let's look at this. We're going to rearrange this to give us another way to find the dot product. So from the law of cosines, we know that the cosine of the angle between two vectors is u dot v over the magnitude of u times the magnitude of v. I can multiply both sides by the magnitude of u times the magnitude of v, and I can get that u dot v is the magnitude of u times the magnitude of v times the cosine of the angle between them. Well, this gives us a second way to calculate the dot product. And for this method, we don't need component form. All we need to know is the magnitude of the vectors and the angle between them. So this gives us another way to calculate dot products. Now let's look at this for a second. What if the angle between the two vectors is 90 degrees? What's the cosine of 90? 0. If theta equals 90 degrees, u dot v equals 0. This gives us a test to decide whether or not the angle between two vectors is 90 degrees. So we're going to say if the angle between vectors we call that, when the angle between them is 90 degrees, we call them orthogonal. Orthogonal is just another way of saying they make a 90-degree angle with each other. We use perpendicular to talk about lines and segments. We use orthogonal to talk about vectors. And there's another word that we'll use when we talk about vectors in relationship to other things. for now, orthogonal means 90 degrees. So we have a test to see if the angle between two vectors is 90 degrees. It turns out that it's useful. It's important information to know if the two angles, if two vectors make a 90-degree angle with each other. All right, so let's, the kind of problem that you might see that has to do with this is the question might say, are u, which is negative 4, 2, and v orthogonal? So what this is asking us to do is calculate u dot v. We could calculate the angle, but now we know we don't have to. U dot v is negative 4 times 1 plus 2 times 2, which is 0. And so our answer is yes. They are orthogonal. So how many of you are in physics? A couple. Few. So if an object is traveling in a circle, what direction is the acceleration? You haven't gone there yet? Haven't learned? And so if an object's traveling in a circle, the acceleration points towards the center of the circle. So the acceleration vector and the velocity vector, which goes in the direction of motion, are orthogonal. So that's one situation where it's important to know that if you're traveling in a circle, then the acceleration and the velocity are orthogonal to each other. That's one situation where this comes up.
I didn't hear that joke.
What's that?
The Heisenberg joke? I didn't hear that one.
You didn't hear it?
We learned about that in AP Chem today.
Yeah, about Heisenberg's uncertainty principle. Did it make you laugh again? Yeah.
Wait,
See?
can you tell it?
The math jokes are the kind you get to enjoy twice.
Tell the
Once
Heisenberg
when you hear them, once when you get
I
them.
didn't hear it once.
The cat one, Schrodinger's?
No, the Heisenberg.
Heisenberg?
Yeah.
Heisenberg's uncertainty principle.
Yeah, I remember.
You multiply the position, the position of velocity, and it's a constant. You can only know each one to a certain. You can't know each one to an unlimited degree of accuracy. If you know the position really accurately, you don't know the velocity that accurately. If you know the velocity that accurately, you don't know the position that accurately.
Well, like, what were you not measure them?
Right. Well, you can't measure them to the same precision at the same time. Because in measuring one, you affect the other one, is the idea.
Well, what was the joke, though? The Heisenberg joke, like, that you told on Friday?
You forget?
I don't remember it.
I should put it on the quiz, maybe.
No.
No, when the police officer asked Heisenberg if he knew how fast he was going, he said, "No, but I know exactly where I am." And the police officer said, "You're going 75," and he said, "Now I'm lost." Yeah. Okay. All right. We can get even more information from the dot product. Even more. All right. So we know that u dot v, one way to calculate the dot product, is the magnitude of u times the magnitude of v times the cosine of the angle between them. Well, the magnitude of u is a length, right? It's the hypotenuse of that little right triangle. And the magnitude of v is also a length. So that means, are those lengths ever negative? No. Magnitude of u and magnitude of v are always positive. So I'm going to say greater than 0. So if we have two vectors situated like so, where we have an acute angle between them, and this is u and this is v, Magnitude of u and the magnitude of v are positive. What's the cosine of an acute angle, positive or negative? In the first quadrant, cosine is positive. If we have an acute angle between our two vectors, u dot v is positive. If we have an obtuse angle, like so, and there's u and there's v. Cosine of an obtuse angle, positive or negative? Negative. In this case, u dot v is less than 0, negative. So if the dot product is positive, we know the angle between the two vectors is acute. If the dot product is negative, we know that the angle between the two vectors is obtuse. And we already talked about this situation. If the angle between the two vectors is 90 degrees, the dot product is 0. So the magnitude of the dot product, or the sign of the dot product, tells us whether the angle between the two vectors is acute, obtuse, or right. What if our vectors are parallel, but in opposite directions? Let me draw that drawing. Whoops. All right, so here is u and here is v, and there's the angle. The cosine of my angle in that case is going to be what? -1. So u dot v over the magnitude of u times the magnitude of v is going to be -1. So that would tell us that those vectors are parallel, but they go in the opposite direction. What if they go in the same direction? They're parallel in the same direction. So like so. No. So the parallel, what's the angle between them? If they're going in the same direction? 0. So the cosine of theta, 1. So u dot v over the magnitude of u times the magnitude of v is 1. So the dot product is going to give us a lot of information. The dot product contains information about the angle between the vectors. So that's how it ends up being applied mostly, is to find the relationship between the two vectors that way. All right, questions? Okay. And I will collect this homework on block day. So you can spend your time studying for your quiz. All right, look at that. The homework all fit on one line.